Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're looking at an example that is going to use the fundamental theorem of calculus. So let's start off by remembering what that is. If we take a function from a to b, and I'm just going to use the word function in here, dx, we know that when we take its antiderivative, and I'm just going to abbreviate that, we get antiderivative of b minus antiderivative of a. And I'm using that terminology in particular because I know we're used to seeing with a capital F and a little f when we look at it in a textbook. We're going to modify that a little bit here because a function and its antiderivative we're going to be using instead here are f prime of x in this problem and our f of x in this problem. So we have a graph of our derivative f prime of x, and we know that f of 0 is 3, so we have two pieces of information, and we are using our fundamental theorem of calculus to find our third piece of information. So we're going to rewrite our function. In this case, we're going from 0 to 3 because notice those are the two numbers that we see popping up here, right? We definitely know what happens at f of 0, and we want to figure out what happens at f of 3. So those are the two bounds that we need. Now, if we place, instead of saying f of x, let's put our f prime of x right there because our antiderivative of f prime of x is our function f. And our upper bound is 3, our lower bound is 0, and here is where our fundamental theorem of calculus comes in. So now we have an equation that we can work with, which is wonderful. We have a few pieces of information that we know. We know that f of 0 is 3, so over here we can substitute in the number 3. So we get 0 to 3 of f prime of x dx is equal to f of 3 minus the number 3. Now, the thing that we're trying to figure out here is going to be this number right here, f prime of 3. That's our goal. So the last thing that we need to do is we need to figure out what is this information here, turn that into a number, and then we can solve our equation. When we're taking the integral of something, we are looking at the area underneath a curve. In this case, it's the curve from 0 to 3 on f prime of x. So it is that bit right there that we just shaded in. And you'll see we have two shapes going on there. I'm going to draw them out down here. We have a triangle. Now notice our triangle has width of 2 and it has a height of 2. And then we also have a rectangle. Oh, let me redo that because it is a smaller rectangle. It has a width of 1. I apologize for the bad writing there, and a height again of 2. So that area we split up into those two shapes that we know how to find the area of. The area of a triangle is 1/2 base times height plus, so there's our triangle, plus our rectangle, which is height times width. And since we know all that information, we're just going to pop that in. We have 1/2 2 times 2 plus 1 times 2. So these 2's are going to cancel and we get 2 plus 2, which is 4, which turns our equation into 4 is equal to f of 3 minus 3 because this 4 is the same as that area right there. And when we solve for f of 3, we are going to get f plus 3, so we are going to have the number 7. So there is our solution there, and a nice way to be using the fundamental theorem of calculus as well as our basic understanding of how to calculate the area of shapes. Always good things to remember. Thank you for listening.